Hello everyone. So we are going to continue our class today. As per the previous class, we are talking about basic number theory, and we stop our discussion on the Euclidean algorithms, which the algorithm to find the GCD of two integer numbers. So today we are going to continue to discuss about sequence and series. So there are many types of sequence and series, but we are going to discuss. I can consider this is the most simple sequence and series, which is first one is the arithmetic, and then the other one is geometry. So after this one, later on the next session again, or if it is still have time to continue today, we are going to talk the next one, recurrence relations. So recurrence relations, but we will see first. If we still have time to continue, then we continue, otherwise we are going to discuss next on. Alright, so let's start the first one, arithmetic. So let me just remove this first. So normally, this is, we see kind of any series, for example 1, 2, 3, 4, 5, and so on. Definitely easily for us to continue the numbers. The next one is supposed to be 6, 7, 8, 9, 10, and so on. Or if the numbers again, for examples 3, 6, 9, then this one also still easy to see. The next numbers definitely will be 12, and then 15th, and then 18th, and so on, like that. Or another examples, maybe 5, 10th, 15th, and so on. So easily for us to see the next number will be 20, and then 25, and then 30. So what we would like to see in here, if we are looking at the difference between one number to the next number, like the one here, we already understand that the difference is each is only 1. So definitely to the next one also it should be difference with 1, and so on, like that. Or the second examples here, we can see the difference is 3. Then the next one definitely also will keep 3, like that. Or the last one here, the difference is 5. Then so on to the next one, like that. Of course, if like this, it's quite easy for us to check, but when the numbers is quite big, or for examples is a little bit difficult to try to figure what will be the difference between the numbers to the next one or the numbers with the previous one, there we need some formula, the standard one, to check what will be the difference, and also possibility if we are been questioning what will be the 100 terms, for examples. Or for examples, like number 1 in here, because this one is quite easy. For example, if someone asks what will be the 67th term. Okay, since the difference is only 1 here, definitely easily for us to set 67. But the second one here, if the questions the 75 term, what will be? Then here we will start worried or start to figure what will be the 75th terms, or over here they ask the 37th term. Then it's require us to do small calculations to find out about this one. Okay, so in arithmetic, because the pattern is following a certain rules in there, so we can try to figure the formula to work with this arithmetic sequence. In arithmetic sequence, there are three things that we need to know. First, we need to know the first term. We call as U1, for example. And then we need to know the difference, B. Then for any given series, if we know U1, which is the first term, and B over there, then that will be easy for us to find the general formula for that particular sequence. So the formula for nth term in arithmetic sequence is formulated by UN is UI U1 plus n minus 1 times B here, which U1 is the first term, and is the term that we would like to find out. B here is the difference between a numbers or a term to the next one or to the previous one. Okay, so consider we have the one here, the second one. The first one is quite easy, so we're not looking at that. So the sequence is 3, 6, 9, and so on. So if we considered this one as the first term, and then we can check the difference between a term to the next one or to the previous one is 3 over there. So the formula for this particular sequence will be UN UI plus n minus 1 times B. So UN will be, U1 is the one that we see there is 3 plus n minus 1 times the difference is also 3. So UN definitely 3 plus, we can solve this model. It means 3n minus 3. So UN will be 3 over here with 3 over here, left with 3n. So this is the formula for this particular sequence. So when we ask about the 70th term, so for n equal to 75, so in 75 terms, so that will be 3 times 75. That will give us 200 to 5. You may check these numbers whether I multiply it correctly or not. Also the same one with numbered the third examples here. So the sequence given is 5, 10, 15, and so on. So over here we can see the difference is 5, and 5 here is the first term. So for this particular sequence, the formula will be u1 plus n minus 1 times b, the difference. So un, we have 5, the first term, and minus 1, and the difference is 5 also. So we have, is 5 plus 5 and minus 5, and over here we can cross, then we get un is 5n. So if we request about 37th term, so it means for n equal to 37, so the u37th will be 5 times 5 times 37, so we got 185. Please check my calculations whether it is correct or not. So it's quite easy, you see, if we know the basic component in the sequence itself, so to find out the formula for the sequence will not be a big problem. Let's just take a look another examples. Let us given a sequence as 5 and then 3 and then 1, like this. Okay, so the questions, what will be u21? So what we need to do first is try to figure the formula for this sequence. As we said, this is as the u1, and then the difference we can see here is minus 2. Okay, minus 2. So we can work this one with un u1 plus n minus 1 times b. So our un will be 5 plus n minus 1 times minus 2. So over here we have un equal to 5 plus minus 2n plus 2. Then we can simplify this, is 7 minus 2n. So this is the formula for this particular sequence. So if the question is u21, meaning n equal to 21, then u21 will be 7 minus 2 times 21. Then we get this as 7 times 42, which will be equal to minus 35. So that will be the numbers. Okay, so again, let me just rewrite again. This is the general form for arithmetic sequence. So un is the nth term, the value for the nth term. Sorry, I use a here, yeah. So let's just stick with u1. So we know that u1 will be the first term, and is the term that we are looking for, and b here as the difference. So the difference can be found by u2 minus u1, or u3 minus u2, or u4 minus u3, or in general we just said is un minus 1, like that. That will be the calculations for B. Okay, so this is what we call arithmetic sequence. It's quite easy and simple to work with. We are going to see some scenario later on, examples of how this arithmetic applied in the daily life. Okay, so the next one is arithmetic series. So we have arithmetic sequence as we discussed earlier. Which is this one, and the next one we have what we call as arithmetic series. So how is it arithmetic series? So given arithmetic sequence, for example, as we have 3 and then 5 and 7th and 9th and 11th and so on. So arithmetic series is the total of the n terms in the sequence. So instead of writing down as this one, in series we write down as 3 plus 5 plus 7 plus 9 plus 11 plus and so on. So when we said total of the first two terms, so the first two terms meaning we are referring to U1 and U2. But since this is a series, it means it's the total. So it's U1 plus U2. So in arithmetic series, if we put S1 meaning total of the first term meaning U1. And if we put S2 meaning total of the first two terms meaning it's U1 plus U2. And when we said S3 meaning total of the first three terms, so U1 plus U2 plus U3 and so on like that. So when we would like to know total of the first nth terms, so the formula will be Sn equal to n over 2 and then U1 plus Un, just like this. However, we know the formula for Un, which is, as we know earlier, it's U1 plus n minus 1 times B. So if we substitute this formula over here to the formula of series, then instead of using this one, we can have another model to calculate the total of the first n terms by n over 2 U1 plus Un substitute with U1 plus n minus 1 times B, close bracket. Then we can simplify this, n over 2. We have one U1, another U1 here, so it becomes 2 U1 plus n minus 1 times B. So this is another formula that we can use to calculate the arithmetic series. So if we try to work with these examples, okay, so we can try it in here. The sequence 3 plus 5 plus 7 plus 9 plus 11 and so on. So if the questions ask about total of the first 4 terms from this particular series, from here we can check first. This is U1, U2, U3, then U4. So the total will be 3 plus 5 plus 7 plus 9. This will give us 24. So we can check with the formula. Okay, we try to make use the first formula first. This is first one, or we can check with the second formula. They should give us the same answers. So since the question is about the 4th term, so meaning n equal to 4. So for n equal to 4, S4 will be 4 over 2, because it's n over 2, times U1. Our U1 is 3, plus UN. UN in this case is U4. Right? So 4 over 2 we get 2, and then 3 plus our U4 is 9. So when we calculate this, we have 2 times 12 equal to 24. So it gives us the same numbers. Also, we can try to make a use the second formula. So either one, we can try it. So with the second formula, that will give us S4, n over 2, it's 4 over 2, times 2U1, which is 2 times 3, plus n minus 1, that will give us 4 minus 1, times B. The difference here, if we check, is between terms to the next one or to the previous one is difference by 2, right? So it's times 2 over here. Then we calculate 4 over 2, we get 2. 2 times 3, we get 6, plus 4 minus 1, we get 3. 3 times 2, so we get 6. So we have 2 times 12, then the final result is 24, exactly the same numbers. Alright, so which one then we use? It depends. You can use this one over here if you have U1 and UN. Or if you don't have the UN, for example, asking about U1034, which you don't have in this sequence. I mean, the number not yet appeared, so you can just simply use this formula. So whichever, it depends on what you already have on your data. Okay, so let's try another examples. So given a sequence as 3, and then let me just try to figure it first. 7, and then 11. That's all. Questions determined U37. Let me just reduce the numbers. Too big is also difficult for me to calculate. U20, and total of the first 10 terms, which is S10. Sorry. Okay, so there are two things we've been at in here. Now we analyze our sequence first over here. So from this one, we know exactly that u1 is equal to 3. And the difference, we can see 7 minus 3 is equal to 4, which is here is u2 minus u1. So either you want to determine the un first and then the sn first, doesn't have any problems, or you just straightforward apply and substitute the numbers into the formula. If you remember them, then it should be fine. As you know, un is u1 plus n minus 1 times b. So immediately we can substitute the number for u20. So it means for n equal to 20, u1 is 3 plus, and our n is 20 minus 1 times the difference is 3. So we have here u20 equal to 3 plus 19 times 3. Then what we got is 3 plus 19 plus 3, we got 67. So the total is 70 is our 20th term, or u20. So that's for the first questions. The second one is S10. So meaning total of the first 10 terms. Okay. Again, if you remember the formula, that will be n over 2, 2u1 plus n minus 1 times b. Okay. So S10 definitely 10 over 2. 2 times our u1 earlier is 3 plus 10 minus 1 times the difference is 4. Right? Yes, it is 4. So solve this one, we get 5. 2 times 3 we get 6 plus 10 minus 1 we got 9. 9 with 4 we have 36. So if multiplied and total this one, 5 times 6 with 36 we got 42. So the total will be 210. That will be total of the first 10 terms, 210. All right. So it's not that complicated or difficult to understand this arithmetic arithmetic sequence and series. Okay, so as long as you understand the general form given here for the sequence, as well as over here is for the series, then all the problems given should be, we can easily solve them. All right, so that is all for this video, and the next video we are going to discuss the next sequence and series, which call geometric, so that geometric sequence and series on the next video. Okay, thank you for watching and see you on the next one.